All right, everybody, we're back, chapter 4, talking about unit vectors right here, and we're at example 4.8. And this one actually will probably look a lot more familiar to you since we're kind of just reinforcing what unit vectors are right here. Remember, a unit vector is a vector, or it's actually a way of describing a vector, describing it as being some value in the x direction, which is what the x hat means, and some value in the y direction. And that's it. So this is a velocity unit vector, so the different parts are going to have velocity units as indicated by right here, meters per second and meters per second, and all we're being asked for is to find the speed and direction. That means, well, what's the full value of its, I can't say velocity, but what's the full value of its speed and what direction is it going? Those values combined together would give us the velocity, which is magnitude and direction. So, well, we have the x and the y component of the vector right here. In fact, maybe it might just be helpful to draw it. It's got a positive x and a negative y, so that means something kind of like that, right? It's got a 3.7 meters per second x hat component. X hat right here, that's got the x, and it's got a negative 1.3 meters per second. Oop, but I ran out of space. That's a y hat right there. That means in the y direction. So all we need to do to find the full value of the full magnitude of the vector is simply use a Pythagorean, right? So the magnitude is going to be the square root of the x squared, the x hat squared plus the y hat squared. So that's 3.7 meters per second, that value squared, plus negative 1.3 meters per second, that value squared as well. Now, it didn't matter that I put the negative in there because the squared cancels out the negative anyway, but what do we have right here? Well, I didn't do this ahead of time, so I'm just going to do it right now with you. 3.7 squared plus 1.3 squared to the 1/2 power. 3.92. That's the value, that's the magnitude of this speed. 3.92 what? 3.92 meters per second, right? It's not the final answer, so therefore I'm going to put a dotted line box around it. But that's a big part of our final answer right there. Okay, what's the direction? What direction is it going? Well, we kind of surmise that it's going to be in this direction right here, so it's going to be probably some degrees below the positive x-axis. But let's find out what that is by using the inverse tangent. Okay, inverse tangent of what? Of the y over the x, right? Or you could say the y hat over the x hat. So 1.3 over 3.7. Notice I didn't put any signs in front because we use the absolute value to give ourselves an angle. So inverse tangent of 1.3 over 3.7. That gives me 19.35. Ugh, that's ugly. I'll just say 19.4 degrees. Okay, that also we are dotted line boxing because it's not the full answer, but if we just combine these two, the magnitude and the direction, well, that gives us what the problem's asking for. So that is the velocity of this rainbow trout is 3.92 meters per second at what direction? At 19.4 degrees. What of what? Well, we've got a positive x and a negative y, so that's going to be south of east. That is our final answer. I would go on to the next example. Well, it's actually not even an example. It's just a problem. I'll show it to you, but I'll actually start it on a separate video. It looks like here. And we have a car changing its velocity, going from that velocity to this velocity going around a quarter of a turn. All right, so we're going to find the average acceleration that this car experiences, but I just want to show this to you so you know which one to look for, but this is going to be started in a subsequent video. So thanks for watching. I'll see you in the next one.